Hey guys! Today's lesson is going to start off with a review of special right triangles. As you can see, special right triangles include the 30-60-90 triangle and the 45-45-90 triangle. After that, I have two examples set up for us, which are super important examples leading into trigonometry. In these examples, we're going to find the xy coordinate, or the ordered pair of the top right vertex of triangles that look like they're placed in quadrant 1. The reason for these examples will come together for us as we discover the purpose of the unit circle. Unit circle is a really important topic at the end of Algebra 2 or throughout really pre-calculus and calculus. I really enjoy trigonometry and the unit circle and all the topics that go along with this, and I think you will too. After we finish this quick review of the special right triangles and these two examples, we're also going to go over rationalizing denominators. We will review the word reciprocal, and we will also come up with a really cool trick for rationalizing reciprocals of expressions that you can see in example 4 and example 5 that I had put those little stars by. As you see, I wrote based on examples 4 and 5, we can make this conclusion. So it'll come in really handy. And the reason we are dedicating time to something like this will also become more relevant as we continue our journey into trigonometry. Sit tight, pay attention, write down everything that's important that you don't already have written in your notes, and let's get started. We're going to start this review by labeling a 30-60-90 special right triangle. The 30-degree angle is the smallest angle in the bottom left corner, so I'm just going to go ahead and label that corner. That leaves 60 degrees for the top right. We're just going to be recalling what we learned in geometry, and the shortest leg of the triangle will be labeled with an x. The hypotenuse will be labeled with a 2x, or double the length of x. And the longer leg is going to be x times the square root of 3. Now let's move on to the triangle to the right, and we are going to label the 45-45-90 triangle. A 45-45-90 triangle is, of course, an isosceles triangle. An isosceles triangle has at least two congruent side lengths and two congruent angles. Could have all three. An equilateral does qualify as an isosceles. I'm just marking this up so we don't forget that the expression that goes on one leg will also go on to the other leg. Now we're going to add in the expressions that we learned back in geometry. The two legs will both be labeled with an x, and the hypotenuse will be labeled x times the square root of 2. It's really important that you realize that the two x's are actually being multiplied by the square root of 1, because the square root of 1 is 1. Therefore, x square root 2 is greater than x square root 1. I've seen people mix it up and they put x on the hypotenuse and then x square root 2 on both legs, and that just doesn't make any sense because x times the square root of 2 would be bigger. So we're going to take a minute right now and go over rationalizing denominators. Before we can rationalize something, we need to know what a rational number is, because if you're rationalizing it, you're making it rational. A rational number is any number that can be written as a ratio. Numbers that can be written as a ratio or fraction are numbers that have either a terminating decimal, meaning the decimal ends, or it has a repeating decimal, meaning it repeats indefinitely. So what kind of numbers are irrational? Non-repeating, non-terminating decimals. Where do they come from? Sometimes from numbers like square root 3, square root 2. If you find yourself working with a radical that you cannot simplify into a nice number, that's an irrational number. Pi is irrational, and so is E, Euler's number. These are all numbers that go on and on forever and never repeat. Radical 3 and radical 2 are examples of an irrational number that cannot be written as a ratio or fraction. What about a reciprocal? Reciprocal, refliprocal. Oftentimes, students are taught what a reciprocal is by being presented with x and then 1 over x. The problem with showing it this way is when you're given a fraction, people start to write down 1 over the fraction, then they have a compound fraction, then they mess up simplifying, and I just feel like let's cut out the middleman, get rid of that whole step. The reciprocal of a number, a over b, is b over a. And just remember, reciprocal, refliprocal. You're just going to flip that fraction over. Now it's time to rationalize the reciprocal for example 3. The reciprocal of radical 3 over 2 is 2 over radical 3. In order to rationalize this denominator, we're going to multiply the numerator and denominator by radical 3. That is not to be confused with multiplying by radical 3. Multiplying a numerator and denominator by radical 3 is multiplying by radical 3 over radical 3, which is 1, and that's very different. Radical 3 times radical 3 is 3. That gives us a final answer of 2 radical 3 over 3. Next up, for example 4, we have radical 2 over 2. The reciprocal of radical 2 over 2 is the reciprocal 2 over radical 2. To properly rationalize this denominator, we're going to multiply both the numerator and denominator by radical 2 over 2. Again, this is the same as multiplying by 1, also known as the multiplicative identity, and this is totally valid. 2 times the square root of 2 is 2 radical 2. Square root of 2 times square root of 2 is technically square root of 4, which is 2. Many times people leave the answer like this, but we can actually go a little bit further, and I hope you see it. 2 radical 2 over 2 reduces to just radical 2. Therefore, the rationalized reciprocal of radical 2 over 2 is radical 2. Example 5, radical 3. Radical 3 is really over 1. In fact, any number without a written denominator is over 1. Radical 3 over 1, to find the reciprocal, would become 1 over radical 3. Again, we multiply the numerator and denominator by the square root of 3. 1 times the square root of 3 is square root of 3, and square root of 3 times square root of 3 is 3. Final answer, the rationalized reciprocal of radical 3 is radical 3 over 3. Let's take a minute to think about examples 4 and 5 and see if we can come up with any conclusions. Take 15 seconds to look at them, look at the answers, and look how they're set up. And I'll show you what conclusion we should have all come to at the end of those 15 seconds. All right, the conclusion you should have come to is the reciprocal of radical anything. Put a heart in that radical, it doesn't matter. The reciprocal of radical heart is radical heart over heart. And the same is true in reverse. The reciprocal of radical heart over heart is radical heart. Knowing this by heart, see what I did there, is going to be very beneficial to you. It will save you a lot of headache. There are going to be a lot of reciprocals you're going to have to bounce back and forth between. There's going to be a lot of rationalizing. There are going to be a lot of things that you are going to commit to memory. Every little trick helps. I really hope that this all made sense to you. If not, I hope you take a few minutes to watch it again, or at least rewatch the parts that you found confusing, because I really want you to do awesome when it comes to the unit circle and trigonometry. Good luck.